Today we're looking at the chain rule, which is used for deriving composite functions. So what is a composite function? Well, a composite function is the composition of two functions. So you might remember when we were checking inverses last year, we would do f of g of x and g of f of x. That was what we were referring to as composite functions here. So for composite functions, we've got some inner function that's replacing our input, and we've got some outer function, right? And that outer function in this case is f. So there's a first round of things happening to x, which is g, and then after that happens, we've got this second round, which is f. So when we're talking about the derivative of this function, we're going to be looking at our chain rule. And the chain rule says, well, we've got the derivative of the outside function. So that's what this is. And then when we do that derivative, we leave the inside function alone. And then once we've evaluated the derivative of f, that outside function, leaving g alone, we multiply it by the derivative of the inside function. So this all may seem a bit funky, all right? But I promise once we practice it a bit, it's quite intuitive, all right? And it won't take us as long as the product or the quotient rule, because there's much less work to do. There's an alternate technique for these problems, and it's called U substitution. But learning it with function notation is more important for our initial encounter, so we'll circle back and look at U substitution later. All right, but most cases we'll be using function notation because that's what the AP exam and UConn favor. So let's look at some examples of the chain rule. So I'm going to start by highlighting my inside function. So the first thing to happen to x is 3x plus 1. The second thing to happen is ln x. So that means my g of x, my inside function, right? This is our format. My inside function here is 3x plus 1. And my f of g of x is this natural log 3x plus 1. So when we're talking about the derivative then of f of g of x, we first need to know the derivative of g and the derivative of the outer function f. So the derivative of g, the inner function, is just 3. And the derivative of the outer function, f of g, maybe this will be less, let's leave this as g of x in here. I think that'll be easier for us to see. Is going to be 1 over g of x. So we multiply these two. So we've got 1 over g of x times g derivative x. So that's going to be 1 over 3x plus 1 times 3, or 3 over 3x plus 1. So let's look at another one. Give it a go. So this is our f of g of x. where our outside function is that 9g of x cubed, and our inside function is 5x minus 2. The derivative of the inside is 5, and the derivative of the outside function, leaving the input the same, is we use our power rule, so we take down the 3 and make the exponent 1 smaller. So I've got 27, and then this g of x guy squared. So our derivative overall is the product of these two. That's what our chain rule says. So we've got 27 g of x squared times 5 27 times 5 is going to give us a value of 135, and then we know that g of x is 5x minus 2. If we wanted to, we could expand that and distribute the 135, but we're just going to call it a day right there. If it'll let me scroll, we've got 4 more examples to look at here in the notes section that I do. Then we've got another 6 to look at as practice before you attempt some on your own. So here we've got f of g of x is our outer function, which is the sine. And then our inner function is the 10x to the 9th. The derivative of this top guy, with the inside staying the same. Well, the derivative of sine is cosine, and the inside just stays just chilling. And then what's the derivative of 10x to the 9th? Well, we bring down our exponent, and we make the exponent 1 smaller. So that guy is 90x to the 8th. Our overall derivative here for f of g of x, our composite function, is the product of those two. So we've got 90x to the 8th cosine, and g of x was 10x to the 9th. All right, so I think we should be seeing a pattern here and be getting to the point where we can try problems on our own. But let's keep on trucking, so to speak. We've got f of g of x here, which is going to be that sine with our inside function being the 3 cosine x, and our sine function. So we do the derivative of each. The derivative of our outside is going to be the derivative of sine, which is positive cosine. And the derivative of 3 cosine, well, the derivative of cosine is negative sine, so we've got negative 3 sine x. The overall derivative of our composite function is, once again, the derivative of our outside with the inside function remaining the same, times the derivative of our inside. So I've got cosine g of x times -3 sine x, which is going to give me -3 cosine 3 cosine x sine x. Okay, we're winding on down here. So we have to rewrite using a fractional exponent. So the fifth root is going to be the 1/5 power. Now we go ahead and do our f of g of x. Our outside function is that 1/5 power. And our inside function, the first thing happening to x is 14x minus 9. The derivative of the outside with the inside staying the same is we take down our exponent and we make it one smaller. So I've got, running out of space here, 1/5 minus 1. So I've got 1/5. 1/5, and then g of x to the -4/5. The negative brings me down to the denominator. And then the 5th is the same as the 5th root. So that's my derivative of the outside with the inside staying the same. So yes, that one's a little more long-winded. All right, and then we're looking at this derivative of the inside, which is blessedly short. What am I doing? The derivative of that is 14. So now we do our overall derivative of the composite function. Whoa, 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 whoa. JK. Which is equal to the derivative of the outside function with the inside staying the same, times the derivative of the outside function, that times the derivative of the inside function. So here we've got 1/5 5th root g of x to the 4th times g prime of x, 14. So it's going to be 14. I still know what 14 looks like. Over 5 5th root of g of x, which is 14x minus 9. That's our answer. Move on over, boot scoot on over. We've got f of g of x. Our second thing happening, our outer function here is the e to the power. So we've got e to the g of x, where g of x is the first thing happening to x, which is a 2x cubed. The derivative of e to the x is e to the x, so this guy just stays the same. And then the derivative of g to the x, bring down your exponent, make your exponent one smaller. So we got 6x squared. Our overall derivative of the composite function, f of g of x, is equal to the derivative of the outside function with the inside staying the same, times the derivative of the inside function. So here we've got e to the gx times 6x squared, or 6x squared e to the, what's g of x? 2x cubed.